Asteroid 2024 YR4. Moon collision ruled out by James Webb Telescope. The Moon will not be impacted by Asteroid 2024 YR4 in 2032, according to refined trajectory calculations made possible by observations from the James Webb Space Telescope, JWST. This eliminates the previously estimated 4.3% chance of a collision. Near miss, not impact. The city killer asteroid will pass within 13,200 miles, 21,200 kilometers, of the lunar surface, closer than many Earth-orbiting satellites. The asteroid poses no threat to Earth either, passing by at a safe distance of hundreds of thousands of miles during its next close approach in 6 years. Pushing JWST to its limits, NASA astronomers leveraged JWST's infrared capabilities to make these determinations, an observation that pushed the telescope to its operational boundaries. The asteroid became nearly undetectable from Earth-based or other space-based observatories after spring 2025, making this JWST data crucial. NASA officials called the observations among the faintest ever recorded for an asteroid, a potentially catastrophic asteroid discovered in late 2024 by the Atlas Network. 2024 YR4 is estimated to be between 174 and 220 feet, 53 to 67 meters in diameter, roughly the size of the Leaning Tower of Pisa. An impact from an asteroid of this size could devastate a major city, with energy equivalent to 500 Hiroshima bombs. Initial calculations estimated a 3.1% chance of Earth impact, the highest odds ever recorded for a potential collision. Improved data from JWST and ground telescopes have since reduced this risk to zero. What if it had hit? Had the asteroid collided with the Moon, it would not have been the first such event. But it would have been the first time scientists could predict and observe a large lunar impact in real time. Experts speculated the explosion could have been visible from Earth, and debris from the collision may have triggered a new meteor shower on our planet. The JWST's ability to observe such faint and distant objects demonstrates its critical role in planetary defense, providing essential data that allows scientists to refine risk assessments and ultimately protect both Earth and its Moon from potentially catastrophic impacts.